Okay, so we're going to start out with the history of the atom. We're looking at the scientists who first discovered or noted that they believed atoms would be there. So the first person is Democritus. He was from Greece. He's the person who said that you would eventually reach the smallest piece, a piece that you could not divide. That's where the word indivisible comes from. So he said you would cut it in half and then cut that piece in half and then cut that piece in half, and eventually there would be a piece that you can't cut in half. The word atom means smallest piece or indivisible in Greek, so that's why he called it that. So it's about 2,000 years later, and somebody decides that maybe he was onto something. John Dalton. He says, yes, I agree with Democritus, but I think that each element has its own specific type of atom. So hydrogen atoms would look different than oxygen atoms, and they would look different than uranium atoms, so that each one had its own type. Thomson is the first person who noticed that there were charges within the atom. He assumed that it would look like a giant cookie, but then like the chocolate chips would be negatively charged. These were electrons, but he called them corpuscles. He did not call them electrons. And he assumed that the rest of the cookie would be positively charged. Okay. Ernest Rutherford discovers the nucleus. Remember, he shoots radiation through different levels of foil. He notices that every so often, very rarely, but every so often, one would be bounced back. So he is credited with the solar system model, meaning that he knows there's a lot of empty space around the big mass in the center, much like how the sun is in the center and there's lots of space between the planets. Okay, so he's the person who discovers the nucleus, Rutherford nucleus. Niels Bohr, just a few years later, proposes that the electrons have specific orbits, that they have energy levels, with the least amount of energy being near the nucleus. So when we say to draw a Bohr model, you put the nucleus in the center. Remember that the innermost level can only hold 2. It doesn't have to have 2, it can have 1, but it can't hold more than 2. The next level can have 8, and so on. So these levels are what he's known for. So this would be a Bohr model. James Chadwick discovers the neutron. This is because he noticed that you can have hydrogen, 3 different atoms of hydrogen, but they all have a different atomic mass. That's because one hydrogen might only have a proton. The next atom might have a proton and a neutron, and vice versa. So he noticed that there were neutrons that had no charge and didn't really affect the atom other than the mass. Physicists Murray Gell-Mann and George Zweig proposed that protons and neutrons can be broken down into quarks, each of them broken into 3 quarks. The modern model, which is by Schrödinger, R-O with the 2 dots over it, and then Dinger, greatest name ever, Schrödinger. He's responsible for the electron cloud model, so this is what we look at today, or the wave model. We know that the electrons are swirling around the nucleus. We know there are protons, neutrons. We know there are quarks. We even know there are neutrinos, which is what quarks break down into. But what he's saying is that they're not on a specific path, that they're just moving around in a cloud and that they can move around in there. And so this is the accepted model today. So it says, can the model of the atom change again? Yes, with newer technologies, you never know what we can discover. Is it likely that most of what they've come up with is true? Yes. The same way that you can pick up a present that's wrapped up and make observations on the shape, how heavy it is, how it sounds when you shake it. you could possibly guess what's in there. It's the same thing. Remember the lab that you did where you had to detect the path of the electrons, and almost all of you at least had one or two of them right, and you couldn't even see it. All right, atom structure. So, subatomic particles are protons, neutrons, electrons. Subatomic meaning inside the atom, smaller than the atom. Okay. The nucleus is also called the core. It's in the center. It is the biggest part of the atom. It has 99.9% of the mass. Inside of it are protons and neutrons. It is positively charged because of the protons. So, protons, positively charged, their mass is 1 AMU. They're so small they can't be measured in grams, ounces, nothing like that, so they have their own unit called the atomic mass unit. In this picture over here, it shows the nucleus, and then it zooms in. You see the orange would be neutrons, the yellow would be protons, and then it zooms into the inside of a proton, and it shows you 3 quarks. Neutrons, they have no charge. They are neutral. They're also 1 AMU. They just want you to know the size comparison, that they are the same size. The number is not specific. Remember, protons have to match electrons. If there's 2 electrons, there's 2 protons. If there's 4 protons, there's 4 electrons. Neutrons can be any number. There can be 0, there could be 5, it can just be random. Okay, it says this particle is within the nucleus of an atom, and it has no charge. It would be the neutron, C. This particle is in the nucleus, I spelled that wrong, of an atom and has a positive charge. Proton, positive. This has a negative charge, electron. This is the part of the atom that's the center, the nucleus, D. Alright, isotopes are atoms that have the same number of protons but a different number of neutrons. We actually didn't go over this in class, so I'm going to skip this. We will come back to this though. Electrons whirl around the nucleus super fast. So fast that you can't get to the nucleus. It's like trying to put your hand through a fast spinning fan. Okay, even though there are spaces between the blades, you couldn't do that. The mass is 0.0006 AMUs. So compared to the proton and neutron, very, very small. They have a negative charge. They always equal the protons. We said that. It says they move so fast, it's referred to as an electron cloud. What you need to know is right here that the energy levels, the first one can hold 2, second one is 8, and the last one's 18. If I ask you to draw me a Bohr model of a specific element, remember that you're going to put them in those energy levels with only 2 being in the bottom, then up to 8, and then up to 18. Okay, we skipped that. The strong force is what holds the nucleus together. Protons are all positive. We know that like charges will repel. They'll push away from each other. So why do they not push away from each other? The strong force is what we call the force that actually holds them together in the nucleus. Okay, this is the last thing we went over. We're looking at a key here. So let's do fluorine. I'm going to round up the atomic mass to 19. Here's fluorine, by the way. This is the symbol and the atomic number. The atomic number, the smaller number, tells me how many protons there are. So I know there are 9. How many electrons are there? They are always the same. Protons and electrons always have the same number, so there are also 9. Neutrons, I'm going to take my atomic mass, which is 19, subtract the little number, which is my atomic number, and whatever's left, which in this case is 10, is how many neutrons there are. You should be able to do this. Try these others. You should also be able to look at an element key. This one's for neon. We know that the 10 here tells me it has 10 protons, so I could put 10 protons right in the center here. 7, 8, 9, 10. It also has 10 electrons. Oops. So I'll put 2 on the inner, and then I'll put 8 on this second level. I mean, normally I would spread them around, but for time's sake, so that's 6, 7, 8. So there are my 10 electrons. I don't need this third level. There aren't any. Okay, and then neutrons, I would take 10, subtract 20, because I could round this to 20, and so then neutrons are also 10. You should be able to do this on your test. Really? 6, 7, 8, 9, 10. Okay, so one more time. Looking at the element key for neon, 10 protons, 10 neutrons are in the nucleus. I have 2 on my innermost level and 8 electrons on my second level, making a total of 10. So this would be correct. Okay, that's the end of this lesson. Good luck.